Okay, so I decided we should look at some more examples of solving inequalities and graphing them. So this first one, 3m is less than 30. Just divide both sides by 3, right? And since that's a positive number, we don't change the sign. And it's still less than. We have m, divide both sides by 3. M is less than 10. So we graph that. Put 10 on the number line. And you can put a few more numbers so it's not lonely. Okay, and then since it's less than, we use a circle to show 10 is not included. And that's it. Shade to the left because it's less than. Let's look at the next one. Here we want to multiply both sides by 3 to get rid of that 3 that we're dividing by. And on the left, we just get x, and x is less than 33. So we shade that. This time I'm just going to show the number 33, nothing else. So yeah, you can just do that. You don't have to put more numbers on there. The circle, actually, this is a colored in circle, a dot we could say, because it's less than or equal, right? So 33 is included in the graph, and also everything to its left. Okay, I'll go to the next one. So this will take a couple steps. First, we'll get rid of the 4 by adding 4 to both sides. So we could write that in like that. On the left side, what remains is 6n, and on the right side is negative 48. So we divide both sides by 6. And we get n is greater than or equal to, let's see, make a little more room here. Negative 48 over 6, negative 8. So that's the solution set. All the n's that are greater than or equal to negative 8. Put boxes around these other ones as well. Okay, so we'll graph that. Greater than or equal to negative 8. We could put negative 8 right here. Negative 8, negative 9, negative 7. Let's say we want everything greater than or equal to negative 8. So we color it in solid. Shade to the right on the number line. That's it. Okay, the next one is similar. Get rid of the 8 first, right? Subtract 8 from both sides. We'll write it in like this. On the left, that leaves 2. 10 minus 8 is 2. On the right, just p over 6. Multiply both sides by 6 to get rid of that 6 down in the denominator, and 2 times 6, of course, is 12. And that's less than p. So we get 12 is less than p, but we'd rather write that as saying p is greater than 12. Okay, if 12 is less than p, p is greater than 12. So we want to graph that. Everything greater than 12, we'll put a couple more numbers in there just for fun. We don't want to include 12, so we put a circle. We want, though, what's greater than 12. That's our solution set, so shade it in. Everything larger than 12. Okay. Now we haven't talked about checking these in these examples, but you can check the boundary condition and then check something a little bit bigger. So 12 is our boundary point, I should say. We don't want it to be included, so we want a false statement when we put in 12. And so let's do that. And so put in 12 for p. 12 over 6 is 2, plus 8 is 10. And that shows that 12 does not satisfy our original inequality, because put in 12 we get 10 is less than 10. That's false. But it shows us, well, it is right there on the edge, right? All the p's that are larger than 12 should work. So if we put in 13, we'd have 13 over 6. That's larger than 2. We don't know exactly what it is. It's a little bit bigger than 2, plus 8 is a little bit bigger than 10, and 10 is less than that. So we find that 13 works, and so that's encouraging, because we are saying that all the p's greater than 12 satisfy the original inequality, and 13 should satisfy it, and it does. Okay, so just got a few more. Let's look at this one. So we're going to subtract 25 from both sides first, right? Just write that in here. Minus 25. Minus 25. So on the left we just have our negative 2y, and on the right we have 8. Okay, so we divide both sides by negative 2, and you've been waiting, haven't you? We're dividing by a negative this time. So we reverse the direction. Instead of greater than or equal, it becomes less than or equal. Now that gives us, got to divide both sides by negative 2. Oh, not there, sorry. Okay, so divide both sides by negative 2, which causes this direction of the symbol to reverse. So now it's less than or equal. We get y less than or equal to negative 4. So we can put our negative 4 right here. This time, well, you could also just put 0 sometimes, or other numbers. It doesn't really matter. Just so you have the ones you need. Let's say 0's right there. And then less than or equal means we color that in. And shade to the left. Okay, y is less than or equal to negative 4. Well, let's look at the next one. Okay, so we've got a few more steps. First, we need to distribute on the left. Negative 4 times 1, negative 4. Negative 4 times negative 4x is positive 16x. That's less than 44. Okay. Okay. so now we've distributed. We add 4 to both sides to get rid of the 4. Okay, we get on the left, what remains is 16x. That's less than, on the right we have 48. Divide by 16, and that's positive 16. Didn't leave quite enough room here. Come on over to here. That's x is less than 3. So everything less than 3 should satisfy it, but 3 shouldn't. And our quick check is if we put in 3, we would have to have 12 there, and 1 minus 12 is negative 11. And negative 4 times negative 11 is 44. So that makes a false statement, because that would say 44 is less than 44. It's not. And so we see 3 doesn't work, just like we said it shouldn't work, because only numbers less than 3 should work. So let's try 2. Put in a 2, you get 1 minus 8. That's negative 7. And times negative 4 is 28. And 28 is less than 44. So it looks good. So we'll put 3 on our graph. And we can put 0 here. And we want to graph everything less than 3, so we don't include 3. We shade to the left. Okay. So now we're just going to look at a couple compound inequalities. And this first one is an OR. So we know we just work out each of them separately. So the first one, 2r minus 2 is less than negative 18. Add 2 to both sides and we get 2r less than negative 16. Divide both sides by 2. Get r is less than negative 8. Okay, we'll do the other side. Subtracting the other part, I mean on the other side of the OR. Subtracting 4 from both sides. On the left you get negative 8r because the 4 is gone. On the right you get negative 40. And so now we're going to divide both sides by negative 8 to get the r by itself. And we will remember we have to reverse the sign in this situation. Okay. Okay, so on the left, we did reverse it from less than or equal to greater than or equal. We have r greater than or equal to negative 40 over negative 8 is 5. Okay, so this is an OR, and that's our solution. And we didn't keep them level. That's okay. Just draw a complicated circle around them, a box. So we're saying r is less than negative 8 or it's greater than or equal to negative 5. If it satisfies either of those, it's part of our solution set. So we graph that. I'll move that over a little bit. Say there's negative 8. We could put 0 about there and 5 about there. And that's enough points to put on the number line. We're saying r is less than negative 8 or greater than or equal to 5. So we're going to have most of the number line is included, but there's a little gap that's not. So less than negative 8 means we make the circle instead of the dot. Shade that in. or could be greater than or equal to 5. So there we use the dot because we want to include the 5 in our graph. Shade that in. Okay. So we got one more, and this is an and. And this is one of those ands written in this form. Let's just show the other way of writing it, okay, which would be -9 is less than m minus 7, and m minus 7 is less than -6. Okay, so we could write it with the and, or we could write it the way it is here. And so the other example we did, we used it like I have here, writing it as an and we did it. And so you can look back at that one in the other notes or the other video. But a lot of times when you do write them this way, it's easier to just use that, and then we can get the m by itself, and this will work out nicely. So we're going to add 7 to all three, and so you get on the left -2, and in the middle just our m, and then on the right a +1. Okay, and then that's it. I have to make a number line here. I didn't make one ahead of time. Now this way we don't have to find the overlap because the statement gives this. You can see the other example in the other notes where we did it the other way, and we found the overlap of the two graphs that come from these two inequalities joined by and. So this time though, we've just got it bracketed already. We know its m is between -2 and 1, and put a 0 there, 1 there, and we have both of those are less than signs, so rather than less than or equal, so that these points are not included, but everything in between, because -2 is less than m, which is less than 1. So we'll shade that. Okay, so that's some more examples. You can also look at the other notes, and hopefully that will help you get that graded review done. So that's all for now.